Okay, ladies and gents, this should be an actually relatively quick one for us. So we are solving some systems of quadratic and linear systems using Desmos. If we were not using Desmos, boy, this would be a completely different story. But Desmos is going to take a lot of the work out of this for you. So what is a system of equations? You've solved them in Algebra 1, so the idea of a system is not new. What is new is that we're going to be looking at linear functions and quadratic functions. Before in Algebra 1, in 8th grade math, you looked at just linear functions. So a system itself of equations involves two or more equations. We'll only deal with two. And when you solve a system, you are looking for the point or points where the graphs intersect. So those are called the graph solutions, the points they have in common. So we can solve these types of problems algebraically or graphically. And like I said, for us and our purposes in this virtual environment, we are going to do this graphically only. So again, you're in luck. We're going to do all of our problems graphically with Desmos. So I've given you an example of what it's going to look like when you graph. You have your two equations. You're going to type these two equations in the two different screens of Desmos. And we're going to adjust the screen so that we can see where does the line and where does the parabola intersect. Just like everything we do with Desmos, what's nice, it does all the work for us. Once we see where the 2 points intersect, we can tap on those points and it's going to show us the ordered pair. And those ordered pairs, again, represent the solutions to the system. So let's do it. So let's get one of these out of the way here. So given these two equations, our goal is to solve this system of equations. What's really awesome about Desmos, you don't have to rearrange formulas in any way, shape, or form. You can type them in exactly as you see them. So I'm going to click over to Desmos, and my first equation was y equals 2x. I'm going to stretch out my screen here a little bit. Nope, can't do it now. Too bad, too sad. And then we're going to y equals x squared minus 3. So y equals x squared minus 3. And it looks like I have enough room in my screen here. Again, I click on either one of the graphs. It's going to highlight the 2 points of intersection. So I click, and I see my solutions to this system are the ordered pair 3, 6, and -1, -2. So 3, 6, -1, -2, and that's it. That's as difficult as these types of problems get. If you can type the equations into Desmos correctly, you should be able to find the point or points of intersection. So let's look at our next one. Y equals x squared. I'm going to clear out these old ones. So y equals x squared. Y plus 10 equals 7x. And like I said, you don't have to rearrange anything. Plus 10 equals 7x. And again, I don't have to retype it. It will solve the equation. You don't even have to change for y. Oh, I'm looking here. It looks like this particular graph only has one ordered pair at 2, 4. Now that's what I can see. I'm going to zoom out a little bit. Oh, nope. And up here I can see another point. So make sure you look and double check to make sure that it does not have an additional point. I can see those two now. So 5, 25 and 2, 4. And then one last one. Okay, again, I'm not rearranging anything. I'm just going to type it in exactly as I see it. So I'll get rid of these two. X squared minus y minus 6. I think it said equals 0. It does. And x plus y equals 0. Okay. And again, right here, you can see the points of intersection. Click on them. There I am, -3, 3, and 2, -2. Now, if you were so inclined to do so, you could check your solutions. meaning that if I take these ordered pairs and substitute them in, I should get two true statements. So if I put negative 3 plus 3 in here, that equals 0. So I know that point works in that group. Negative 3 squared is 9. 9 minus 3 minus 6. 9 minus 3 is 6. 6 minus 6 is 0. And I can see that that ordered pair truly does work. In order for a ordered pair to be a solution, it must make both equations true. And we could apply the same practice with this little guy here and test him, and we could find out that he works. But that's the idea, and that's as tough as this gets. Can you put the equations into Desmos correctly? Can you identify the point or points where these graphs intersect?